Hello guys, welcome back to another video. In today's video I'm going to continue the part 15 video for building for showing you the project that I done. And in the last part video I was ended up showing you half through of the project, one of the project that I done, and in this video I will try to finish that, showing you that project, and if I got time I'm going to start showing you another project. And so without further ado, let's get to it. Okay guys, I'm back, and in the last part video we ended up here, and this is we loaded our data into here, and we just iterator here, which means we can convert into numpy, and we can access it by just indexing by using next, if I'm not wrong. And I'm still have to learn more about this stuff, but and then we give some batch here, one batch, and we say dot next. We're going to randomly choose some one of some index from here, I think so. So from, if you say batch 0 dot shape, we're going to show us the shape of that one picture we just did here, and the batch of that we're going to be the batch of one will going to be 32 images here, and the first index for the batch will going to be the images, and the second index will going to be the label, which is 1 or 0, which means when I when I prepare the data, I think I changed it as the dog to be 1 and the cat to be 0, and that's 1 and 0 stand for. And so the label will going to be numbers, and those numbers are stand for those values, cat or dog. And that is if we next some batch, one batch will going to be randomly get here when we are running again and again. So, and when we visualized it is images looks like, to do that we can plot subplots, and we can give it n column 4 and figure size to be 20 by 20, which is 20 by 20, I think so, and n column, which means 4, 1 2 3 4, and for idx and image in enumerator batch 0, which is this one, and the first one up to the fourth, the batch of 0 up to, instead of 32 everything we just did until 4, but the 4 is not going to count 0 up to 3, which is 4 images. These are the 4 images for this batch next first 4 values here. So we just plotted here by just saying ax idx, which is the number of this batch, and we just say dot image show dot image means the value of this idx is the number of the data. I hope that makes sense. And ax will going to be the batch, I'm sorry, this one, this place for the first time when we are loop through, and when the second times we're going to be this one. Hope that makes sense. No, ax ax will going to be this, but in 4 different way, and idx will going to be index for this. It is take too much time to explain it, but I hope this later explanation makes sense. And we just image dot as type int, we just change it image as type integer, and here we just give it some title based on batch 1, which is, if you see here, batch 1 is the label, so batch 1, and we just index it by idx here by the number of that, so it will give the title for them 0, as you can see at the top of the plot. So it just we can plot this way, and we will, to fit into our model, we have to make the, not we have to, but to get a good model, we have to make the number to be 0 up to 1. So we just seen here the batch 0 max, and it is 25 because it is 25 by 25 pixels. So we know that here we just got the information here, and we come here and we data to be data equal to data dot map will going to be help us to work some mathematical works, and we just change it with lambda, which is, it is also this one also some complex to understand it, but this x value will going to be, we just say lambda x comma y, the data x will going to be the image data image column, y will going to be the label, right? So we just say lambda x column y for, and then we change it this form to be like this. We just change it x to divided by 255, and we can get the value to be 1 up to 0. We're not gonna so we can just divide it the x value, which is the pixel value, by 255, and we can get the value to be 0 up to 1. And if you see, okay, I think we're not plotted how we did. Okay, and we can change the value by doing like this, and here we just give it scaled iterator to be dated as numpy iterator, just we did in the up here, in the up of the code. And if you see the batch dot scalar iterator dot next, we can get one batch by doing like this. And here if you see the max, it will going to be 1, but here it was 255. So if you wanted to plot the image, we can just use the same step we use there, and those are the same as the one before. We just only change this to be float, so in that way we can just plot it the same way, the same image. But this is the pixel value is between 0 and 1. And if we see the data length, it is 42 batch, and we specify the train size, value size, and test size, and we just did the length of data times 0.7, and we changed that to be integer, so it will going to increase, or if you get 0.4, let's say if you get 3.4, it will going to take it into integer to 3. But if you get 0.5 and above, we are going to get 4. 3.5 up to above to 9, or yeah, up to that we're going to be 4. So, and we just added up here because we get 2 extra, so for that reason we just added up for value and test size. If we multiply, if we calculate those, we are going to get 2 extra, so we just added up for val and test 1. And if for train size we have 29 batch, and for validation size we have 9, and for test size we have 5. And we just use take and skip method. This will going to be take some size here, and for when we this for the other one, it will going to skip this one data, and it will going to take this one from this data. And that we did here. And if you see the length of that we did here, the same as this length. And here we just imported a sequential, which is the model we used to build, and this is the layers we use: converse 2D, max pooling 2D, dense and flatten. This is a big topic to talk about it. It doesn't have enough time to just talk about in one video, so I'm not going to do that. So I just give sequence to have model variable, and we just added some labels. So we just here added conv 2D 60 and activation to be rel, which is a negative to be 0, and other positive value to be same as there, and input shape to have the same input we have there. So, and we just we did also max pooling 2D here, and we repeated this, but the neuron here is 16, but here it is 32. And also this is the same, but 16 again. You're not gonna get this number right away. You have to experiment with when you are working with deep learning. And we flatted every data here, and then we just do dense to 15 and activation relu, and every activation is relu. And in the final part we use sigmoid, which will going to be 0, I think so, 0 up to 1, infinity. It does not going to touch the 0 or the 1 in the y value, but the x value, the more the x value go to the positive infinity, it will going to close to the y1 value. But when the x values go to the infinity value, we're going to closer to 0, but it does not going to be 0 the y value, or 1 the y value. So that's what the sigmoid value is going to do. And we change it to 1 value, so we can just get it. Is very complex, you're not gonna understand it, I know that. Okay, and here we compile it by using Adam step. We use Adam to compile it, and loss to be binary cross tropy, and matrix we use accuracy. When we train it, we are going to print out the loss and the accuracy, and we use the Adam step to use. By default, I think it is 0.00, I think it is 0.001 step, it will going to take to get to the real value, which is I think like going down into the hill. The loss will going to increase by 0.111, and the more the step is high, the more it will going to closer to the in the short time, but the less it have, it will going to take much time to get into the real value. And here we summarize the model, and here we specify the log directory to be logs, and this will going to be help us to visualize. If you're using TensorFlow, we can, while it is training, you can go to in the website in your terminal, and you can see in very deep way your it's also, this is also some topic takes too much time to explain it. And here we say TensorFlow callback and the log directory here, and we just do that here. And here's the big part here. We just filter, and in the 20 epoch we get about 0.99 accuracy, and we got only 0.0034 loss, and for also validation accuracy and values also we get this number. I'm not going to explain what validation and accuracy other stuff is, because it takes time to explain it. But and we see, because here we specified to have some variable here, we can visualize the train history, so we can also plot it like this way. As you can see, we specified figure variable to have pt figure, and we plotted. So by doing that, it takes time also this to explain. I'm just taking the time to just show you my project that I done, so I'm not going to but it will going to look like if you code like this. So here we imported matrix precision, recall, and binary accuracy to see our prediction. So here we just tested, we predicting in the data that doesn't seen before, and it is predicted here, and we printed out those accuracy, and it got 0.9, 0.8, and 0.89, and it is a good prediction. And here also we take some data from some web, and we pass it through, and we just try to predict it here. So we just plotted here first, and here we resize it into 0 to 250 by 250, and also I think we change it to also I think we have to change also, yeah, here we divided into 256, not, I think this have to be 250. Okay, it's because we change it to 256, so we divided it by 256. And here we predicted here also. While we are predicting, we resize it also. So, and we got y hat here, and so it's predicted to be dog, this image. We can create some class or some function. We just only have to put one predicted dog. So yeah, and we just imported load module, and then here we saved our module, and we can get it where is it? I create some module name. Yeah, here I save it in this folder, this module we use. So to test it out, if the new loaded module is work, if the saved module is work, we just give new module equal to loaded module and we load it the module we saved it here. So here we predict. So guys, yeah, this is the project looks like, and I see you in the next part video. I hope to see you there. Goodbye.